For our final video for section 4.7, we're going to just do some graphs for inverse functions, but you won't really be asked to do a lot with these. This is really just a chance for you to see what the graphs are, visualize that, and maybe give you another modality of looking at inverse trig functions and maybe help make sense of the problems. So let's go ahead and start off by just talking about sines. We're going to be graphing inverse functions. And we're going to be graphing sine, cosine, and tangent eventually, but I first want to just kind of build up to it. So if we were to graph sine of x, we know that sine of x is the graph that looks kind of like that, right? So here's our graph of sine of x. Now for the inverse function, I don't know if you remember this from chapter 1, but we talked about with inverse functions, you switch x and y. X and y replace each other, meaning the inputs and the outputs switch. So we would be graphing x equals sine of y. And let's take a look on Desmos what that looks like. This is also a chance to show you that Desmos is a really powerful tool. This is your testing version of Desmos. You can graph equations on here that look like this. This is not actually a function. So what's pretty cool compared with, say, a TI graphing calculator, Desmos can actually graph equations which are not functions. Now anyways, back to our actual problem here. We have an issue because the inverse function is not actually a function in this case. This doesn't make any sense because if you try to put a vertical line in here, let's say I had x equals 1, notice that that line hits the graph in many spots, which means that this cannot actually be a function. So we have an issue. If we're about to do this graph, if we're trying to come up with some sort of inverse function, by the way, if you were to solve this, you would get y equals sine inverse of x. We have an issue because this is not actually a function. So what mathematicians do when we find out the inverse relationship is not a function is they do what's called a domain restriction. This is also true for a much more common function that you're familiar with, which is called the square root function. A domain restriction had to be implemented. So let's take a look at our graph again, and I'm going to go back to x equals, I'm actually going to go down to -1 here. And, oops, -1. And then I'm also going to do x equals 1. And you'll notice that if I take this point here that goes from -1 to 1, and I'm looking at the y values -pi/2 to pi/2, this is actually, this region in here is a function. So let me go ahead and sketch that out. If we just talk about this region right here, that actually is a function. And so essentially what we're doing is we're taking our original sine function. Let's go ahead and graph that again. Y equals sine of x. And we're restricting our domain to just go from -pi/2 to pi/2. So there's a lot going on Desmos now, so let me go back to my notes here and just kind of show you what's really going on. So we have our sine graph that looks something like this. We'll just say it continues on from there. We have -pi/2 here and pi/2 there, and then we have -pi and pi. And so what mathematicians said is they decided that instead of taking this entire graph, we're just going to stick to this region right here and see what happens when we flip that. And so when you graph this, we're actually just looking at that one little spot I showed you from Desmos. So it's going to go like that. So we're taking just this region, and this region here is actually the blue region for sine of x. So here we have sine of x, and it's being restricted from negative pi over 2 to pi over 2. Oops, this is called the domain restriction. And for the graph of sine inverse, we are just now limited to this region right in here, this little window. Now, once again, x and y are changing, so that means that my x values are actually going from -1 to 1, and my y values are negative pi over 2 to pi over 2. But what's nice is that we actually now have a clearly defined function for sine inverse. We don't have to worry about where we are on this graph. But this is why when you solve equations, you'll notice in previous videos I said you actually get two answers. That's because your original answer that the calculators is spitting out has to be in this region from negative pi over 2 to pi over 2. But we know that there are more possible answers than that. Let me go back to Desmos here and show you that all is not lost, because you can still graph sine inverse of x, and it actually does give you this point here. We could even change our y-axis to go up by pi over 2, since we know that the function is, it's going up by pi's rather than whole numbers, and so you can see that this is in fact negative pi over 2, and this one is positive pi over 2. So just to kind of, again, wrap this up, let's give our actual graph for sine inverse of x. You should be able to recognize this. We're starting from here on the x and there on the y, and the graph kind of looks like that. So it's sort of a sideways sine curve, and this is the graph for sine inverse of x. Notice that its domain is -1 to 1, which was the range for sine of x, and then its range is that domain restriction we found for sine. And so this is what we would say for domain and range. Okay, now what I really want you to get out of this discussion right here is the domain restriction is a really common technique used in math in order to come up with an inverse function, but I also want you just to be able to kind of recognize the sine inverse, and that's really it from this topic. I'm not going to ask you to do any more beyond this in pre-calculus. So let's go ahead and take a look at cosine and kind of do the same thing. So cosine goes along here. This is 2 pi, this is pi. And so mathematicians for cosine, they decided to restrict the domain just from here to here. And so when you flip this, you actually end up with almost a backwards looking graph. Oops. And I just did it wrong. I did a sine graph instead. Sorry about that. Whoops. So what we're actually going to see here is it's going to look like this. So that blue curve I'm taking, I've rewritten it like that. And I really don't like how this turned out. So let me just go ahead and delete that whole graph and redo it. Okay. Sorry for the errors there. So we have x to y. I'm going to be going from -1 to 1 again, except now my y value is going to go up to pi, because this domain restriction is from 0 to pi. So that means my range is going to be 0 to pi as well. We're going to go through the point pi over 2 right here. And then you'll notice that this is the point 0, 1. So it's going to turn into the point 1, 0 for the inverse. And then we have the point pi -1. That's going to turn into the point -1 pi, which is right here. And then our graph is going to kind of curve through that point. And this would be our graph of y equals cosine inverse. Now, once again, we can double check this in Canvas. So y equals functions cosine inverse of x, and there you will see the graph we just came up with. Okay, now finally with tangent, oh, and let's go ahead and just write down the domain. So domain is still -1 to 1. The range is that domain restriction. Okay, now with tangent, this one's going to be sort of a little bit different. So with tangent, we have a bunch of sort of x cubes, we said, from a previous video. And so mathematicians decided for tangent that they're going to take this chunk and flip it. If you take all of them and flip it, you'll again not have a function. So mathematicians said we'll go from -π/2 to +π/2 here. That's where these asymptotes are. And they said we won't actually include the asymptotes. So our domain restriction for tangent is going to be -π/2 to π/2. And so if you flip that part of tangent, you end up with a graph that sort of looks like this. And it never quite gets to π/2, so, or -π/2. So these are horizontal asymptotes for tangent inverse. It goes through the point 0, 0. At 1, it equals π/4, because that's a point on a regular tangent. And at -1, it equals -π/4. So for this graph, we actually have an infinite domain. It's all real numbers because it can keep going in all directions, but the range is limited from -π/2 to +π/2. Okay. All right, so once again, you should be able to recognize these inverse functions when you see them graphed. And also you should understand this concept of doing a domain restriction in order to come up with an inverse relationship that is actually a function. And that is now the conclusion of section 4.7.